students, I'm here with the 2025 paper 1 question 7, and the question reads, find the term independent of x in the expansion of x squared minus 1 over 2x squared to the power 10. Okay, so I've been asked to find the term independent of x. So the term independent of x, they simply mean the term which is x to the power 0. Okay, so this is what they mean by the term independent of x. So we have our solution here. Okay, so we have this binomial expression, which is x squared minus 1 over 2x squared to the power 10. Okay, so for us to find the term independent of x, we need to use this formula: n choose r multiplied by a to the power n minus r multiplied by b to the power r. Okay, so multiplied by b to the power r. I believe this is familiar with us. Okay, so this formula where n is equal to the power, which is 10 here, where n it's the power which is here, and in this case we have 10 as our power, but we need to find r for us to know the term independent of x. So this a, we get the first term which is in the front. So in this case, the one which is in front, it's x squared, and b, we just get this particular term which is at the end. Okay, so we can write our data. So under our data, we have said that the first term, it will be our a. So we can write a is equal to x squared. A is equals to x squared. A is equals to x squared, and b is equal to, so be careful when you're picking this term. If you see here, this as a negative sign, so this means that we're going to get it together with the negative sign. So our b will be negative 1 over 2x squared, negative 1 over 2x squared. So under indices, this 1 over 2x squared can be also written as negative 2x to the power negative 2. So writing as like this is same as writing like that. Okay, so let's prove that this is equal to that. So negative 2x to the power negative 2, we want to prove it that it's equal to this. Okay, so this simply means that it's a negative 1 multiplied by 1 over 2x to the power 2. This is what it means. Okay, 1 multiplied by 1 over 2x squared, and then if you multiply this, it will take you back to this state. So writing like this is the same as like that. Okay, so we can conclude that our b, it's negative 2x to the power negative 1. So this is our b, negative 2x to the power negative 1. So now we just replace in the formula of ours, which is n choose r, n choose r multiplied by a to the power n minus r multiplied by b to the power r. So I'm going to rewrite the formula. So our formula I've said it's n choose r multiplied by a to the power n minus r multiplied by b to the power r. Okay, so I've said our n, it's 10, right? Our n represents the power which is used in a binomial expression. In this case, it's 10. So we're going to have 10 choose r multiplied by our a. We have said our a, it's x squared. Our a, it's x squared, and don't forget the a, it's powered to the power n minus r. So we're going to have n minus r multiplied by our b, which we have said to be negative 2x to the power negative 2, and then this is multiplied by r. It's multiplied by r. So 10 choose r, we maintain our 10 choose r multiplied by x. So these two can multiply by this power according to the law of multiplication of power. So we're going to have 2 multiplied by n. So our n, we shouldn't forget that our n, it's 10. So where there's n, there is 10. So we're going to have 2 multiplied by 10. This will give us 20 minus 2 multiplied by r. This will give us 2r multiplied by. So this part can be also written as negative 2 power r, negative 2 power r multiplied by x to the power negative multiplied by r, negative 2 multiplied by r, we're going to have negative 2r. So writing like this is the same as writing like this. So the reason this negative 2 doesn't have a power of negative 2r, it's because here the power of 2, it's 1. Okay, it's 1, so it will be 1 multiplied by r, which will give us r. So writing like this is the same as writing like that. There's no difference. Okay, so remember the term independent of x is x to the power 0. So this term of x, they are equal to the term independent of x, which is x to the power 0. So for us to find the value of x, we need to equate these terms that have x to the power 0. We need to equate it to this. Okay, so we can have this, which is x to the power 20 minus 2r. We even get this one, which is multiplied by x power negative 2r, power negative 2r. So we have said that this is equal to the term independent of x, which is 0, which is 0. So according to the law of multiplication under indices, it said that when you're multiplying numbers of the same basis, you just add the power. So in this case, x and x, they are the same basis, so we're just going to add the power. So we're going to have x to the power 20 minus 2r. We also add this, which is negative 2r is equal to x power 0. X power 0. So if you see here, we have same basis, so this and this can cancel. I believe we know this. So we're going to have 20 minus 2r minus 2r is equal to 0. So 20 minus, so negative 2r and negative 2r are like terms, so we can add them. So negative 2r minus 2r, this will give you 4r is equal to 0. So then you just collect the like terms so that you find the value of r. If you want, you can just take this side. That would be very simple for us. So we're going to have our 20 is equal to negative 4r. Then we divide, when it crosses the equal sign to be positive. When it crosses the equal sign to be positive, because when a number crosses the equal sign, its sign changes. So over 4 over 4. Okay, so 20 divided 4, this will give us will give us 5. So 5 is equal to r. 5 is equal to r. So the value of r is 5. Okay, so back to this stage where we reached. So this stage was just to find this whole step was just to find the value of r. So since we found the value of r to be 5, it's now easy for us to find the term independent of x. So these all things we have, these all things, it's the term independent of x. So this means that this it's to the power 0, because if you want, you can prove where we have 20 minus 2r. So we found our r to be 5. So we're going to have 20 multiplied by 20 minus 2r, which is 10. So 2r it's 10, so we're going to have 20 minus 10 to give us 20. Even this side, it's 20 minus 10 to give us 10, and then this side we're going to have negative 2 multiplied by 5 to give us 10, so it will be 10 minus 10, hence we're going to remain with 0. So it's just to cancel this term, hence you are remaining with 10 choose r multiplied by negative 2r. So we have 10 choose 10 choose r multiplied by negative 2 multiplied by our 2 here, which is negative 2 to the power negative r, negative 2 to the power negative r. So we're going to have our r, which is 5, so we're going to have to the power negative 5, to the power negative 5. Then 10 choose our r found to be 5, so here there will be 5. So you just press on a calculator 10, choose 10, choose 5. This will give you 252. 252 multiplied by negative 1 to the power, or negative 1 over 2 to the power 5. 2 to the power 5. So when you multiply here, 255 multiplied by negative 1 to the power 2 over 5, you're going to have negative 252, negative 252 over 2 to the power 5, 2 to the power 5, this will give you 32 to the power 5, it's equals to 32. Then you just divide 252 divide 32. So just do 252 divide 32, and this will give you 7.875. So this is the term independent of x. This is the term independent of x. So if you want, you can just write this as a fraction. Okay, so as a fraction, we can write this as 63 over, so 2 into 4 into this, it will give us 63, and 2 into 32, it will give us 8. So you can leave it like this. Okay, so if you don't know where the choose is, you can just come in your calculator and place here. So like we did 10, we place 10, and then just place only choose, which is here. Okay, then you place 5, then you just place equals, sorry, you place 10, you place choose, which is here, you place 5, then you place equals to give you 252. So we are a School of Online lesson, and if you would like to learn with us, you can reach us through this WhatsApp line plus 26096159865. This is the WhatsApp line you can use. So kindly share and like the video. Don't even forget to follow and subscribe. I greet you